Hello, everyone. How are you guys doing today? Good. So we have a little bit of a YOLO agile presentation. So my co-speaker, unfortunately, is sick, so we had to swap Nate. So James is the new Nate. So we're gonna do this a little bit in the agile way. But welcome, everyone. Thank you for coming to our talk. We're gonna talk about vulnerability, threat-centric approach, and a practitioner-to-practitioner approach on vulnerability management. I've been in this industry quite a while. I've seen things that you human can't imagine, things fixed by SLA, product team asking to fix Kubernetes cluster by patching system or by tracing who owns that particular node. So I've seen it all, and who can mention where I take this meme or this picture? Yes. Fantastic. We have nerds in the room. I'm glad because I'm going to use plenty of jokes around the presentation because somebody said, if you talk about heavy stuff, you should have a kitten picture or a meme. So this presentation is going to be full of jokes, memes, and also very deep, serious stuff. And we try to balance it across. So works? Yeah. So we have Nate Sander here, or James is a new Nate. I'm Francesco Cipollone, for folks Franks, or for friends Franks. I've been in this industry for 25 years and counting. I've been leading application security and cloud security program. And what I'm going to use on this speaker note is, in this speaker presentation is, you can argue with people, but you can't argue with data. It's very easy to argue or have an opinion about something or a vulnerability or an exploitability, but data is actually hard facts. So it's very hard to argue with people if you have data. So unfortunately, my co-speaker is not here. So James is a new Nate.
Hello.
You want to take it off?
We've transformed. Yes, my background, until 8 months ago, I was a security engineer at different cloud native companies, so ReliaQuest and some different startups, and then most recently at PagerDuty, where I was a part of our initiatives to get FedRAMP authorized, and we obviously have a very cloud native architecture stack, and so I was just as much in the weeds of all of that, and now I do Latio, which is just a way to try to help engineers find security tools that they can use to make their lives easier, hopefully.
Go for it.
So at a high level, what we're trying to accomplish in this talk is two overarching ideas. The first idea is, how has the cloud really changed the way that we need to approach vulnerability management, and the idea of even context and bringing context to all of these things, from application security owners to infrastructure security people to cloud security people. How do we unify that story in a way that makes sense? And then the second part is, how do we prioritize vulnerabilities in a way that actually allows us to better deal with this new scope of vulnerability management that we're dealing with? And so that's the threat-centric idea that Frank's going to be talking a lot more about, in terms of how does a vulnerability actually translate to a real risk or a real threat that's happening. Switch over to the old-fashioned way. All right, so we're going to start by saying to put your hands up if you believe that your company has a functional vulnerability management program, and if you believe that it covers all areas and scope of vulnerabilities, and if you are prioritizing all your findings by normalized risk. Is that for all three? We got one. So the goal of our presentation really is to say that we don't believe you, and to see that hopefully by the end of it is to show why this is a lot more complicated than it feels like. And the main context for this is, how many of you have been doing vulnerability management since like 2015 and before? Which, it's weird to be able to say that now because I was always like the youngest guy, and now I'm not. 2015. But when I was doing this, right, I was at different MSPs on vSphere type architectures and data centers, and vulnerability management was honestly so much more simple in those days, because we were either using a network-based scanner that was checking the headers of different systems that were out there and saying, here's what version it's on, here's the version to move to, and that was kind of it. Or maybe we were advanced in using like Tenable and scanning different instances for what vulnerabilities are there and moving on from that place. But with the cloud, we have really seen just the explosion of vulnerabilities. And I think a lot of us bought into this idea, if you were like me, of doing shift left scanning, and it's going to make all of our lives easier because we're going to get all of these vulnerabilities fixed earlier. And I think an unexpected side effect of that was actually uncovering the nightmarish complexity of vulnerabilities that exist in modern environments. Because no longer are we just looking at that base OS level of what OS are we on, what do we need to move to? But now we're looking at software composition analysis. We're looking at container vulnerabilities. We're having to trace those vulnerabilities as they're deployed out to production. Companies have adopted open source in a way that I was going to say, I don't think anyone really could have predicted the scale and the speed in which, like, as a developer, I can increase our attack surface in 2 lines of code that just say import Python, or not Python, but import Pedantic, or import the OpenAI agents SDK. And all of a sudden I've opened this whole scope of vulnerabilities that before we were honestly just blind to, because we were just sort of scanning systems. And in light of that, we are creating a ton of pain that I've experienced, that I'm sure everyone in here has experienced, especially when you try to take a modern cloud environment and suddenly you are asked to account to FedRAMP timelines, where you have to meet these SLAs for 30, 60, 180 on high, mediums, and lows, or 30, 90, 180, and how you're actually trying to meet these remediation timelines in a way that honestly just doesn't scale with the amount of scanning that we're trying to do. And we've really become lost in this sea of different scan types and vulnerabilities and figuring out how we're even going to remediate them in the first place.
So raise of hand, a quick question. How high or how many vulnerabilities do we have right now in the MVD? Who can guess a number? Sorry? A little bit less? A little bit more? 262,000, or when I last checked, it was 262,000. Chris, you remember last pass that you did? How many? Well, yeah. And we've seen an increase of 40x from 2015. So a dramatic increase in the number of vulnerability. We can't keep pace of it. And if we keep on growing at this particular rate, we'll probably by 2031, we'll see 1 million worth of vulnerability if we keep on growing at this pace. So this is not doom and gloom, but it's just to say there is a lot of them. There is a lot of vulnerability, and there are very few of us, because we are growing at basically 6% year on year in terms of vulnerability management budget invested.
Well, that's your staffing line probably looks very different than the NVD vulnerability.
Yeah, totally. And things are not going to get easier, but they're going to get worse. And I'm not painting doom and gloom, but the reality of it is everybody's vibe coding out there, or 50% of new code generated is vibed code. Who's aware of the vibe coding industry? Hands up. So vibe coding is just LLM or code generated. That was the old stack trace, copy and paste. Now we just accelerated it with LLM and saying, can you just generate this? And there is a very well-defined difference from, I think my friend James Manico have created a whole course on how you can vibe code securely things and what are the prompts that you can ask an LLM. But 90% of the people that are out there will not ask secure prompt or how to generate secure code. And our coder are not the only one who's going to be in there, but also attacker are fundamentally developing GPT style code scanner or finder of exploit and generation of exploit. And that's why exploitation time went from a critical perspective from 15 days to 3 minutes from declaration point. That's a good example of JetBrains being declared and Cloudflare identifying the first exploit after 3 minutes of exploitation.
I posted on Twitter after the Ingress Nightmare vulnerability came out, and I just copied that blog post into ChatGPT and said, create an exploit. And then it very happily created a payload for me and asked if I would like it to have RCE or have a C2 server to call home to. And so it really is like as soon as a vulnerability gets declared, you're able to just create an exploit automatically, even for someone like me that doesn't even know C, but all of a sudden I have the ability to create C exploits with shared libraries and really just a new level of attack sophistication.
Yeah. And look, we're not coder experts, so somebody with a little bit more knowledge can generate something more refined. But the ultimate thing is these tools have given attacker scale, speed, and evolution. And if we don't adapt, they're going to win. But one of the challenges that we have in this industry is we've seen application security and environment security or cloud security and infrastructure security as two separate things. And in a way, they are separated. So we're going to go through the presentation saying they're the same, they're linked to each other, but they're also different things. And I don't have a real answer for that. But they're definitely correlated to each other. And as a vulnerability management program, we need to realize that we need to cover both of them. And a vulnerability management program that covers one area and doesn't cover the others is a failure.
I think there's a huge question of how do we scale this, where I was blown away by meeting with former Netflix teams who, whenever a new vulnerability shows up, they'll threat hunt in their environment for indicators that that vulnerability's been exploited. And that's just a level of maturity that I've never been a part of, where it's like, I'm lucky when a vulnerability shows up that I can even get it ticketed and get the remediation process going in the first place. But really, it's what we should be doing is checking for, have we been exploited for this? And it requires coordination across the security operations team, DevOps, dev, and a level of cross-team coordination that most organizations just really struggle with, because the skill set is so crazily diverse between a developer and a security operations analyst.
And the way we traditionally handle things is we just run scanner. And the scanners tend to be at least blind to the context where things runs. But the nature of application security, Kubernetes, code, web dust, and so on is so complicated that sometimes as security professional, we just give up and say, fix all of this stuff by SLA. And by the way, can you try to figure out what stuff do you own? What is the result of that? Show of hand if any developer has ever listened to you after you said, fix all of this stuff by SLA X, Y, and Z. Who's been lucky enough to be listened to after that sentence? No one?
Maybe the first time, but then they learned pretty quickly not to do it.
And the way we tend to approach this is just dump all of this into Excel spreadsheet, Power BI generated dashboard. Here's all of the problem that we have in this code scanner result. And then developer, go and find your own problem. And the challenge with this is attacker needs to be right one time, while developer and defender needs to be right all of the time. And what that happen is you get the bonus of shock executive saying, we have spent tons of money on developer tools and shift left and scanner. We scan all of our environment. Why can't this be resolved? Well, because of two reasons: asset ownership and attribution and fixes and collaboration. 4 reasons, actually. So I'm not going to bother you with this, but shock executive, we introduce SLA while we're not fixing stuff. And the other reason is we get a superstar vulnerability a month, while we used to have a superstar vulnerability on a yearly basis. This is just the last probably 3-4 months of major vulnerability being declared. And I think in the last month we had TJ Action and Ingress Nightmare just in a month.
And the Next.js auth bypass. It was like I was writing all this stuff on TJ Actions, and then the Next.js auth came out, and then it was 2 days later Ingress Nightmare happened, and I'm like, I didn't even have time to figure out what the Next.js auth was, and now we've got the next thing.
And the nature of these beasts is they're going to keep on popping up. NPM was the latest one that North Korea threat actor are now targeting. So being able to say, I have this problem on this package, who owns these particular things, and can we focus on a campaign on saying, are these things exploitable and who needs to fix it, is not anymore an option. We need to get to that point. And to get to that point, we need a concept of application, a concept of environment, and a concept of attributing all of these things to the right folks. So the question we should be asking is not anymore how many problems we have and how low should we go, but really who owns what and how important it is, and should we fix it? But most importantly, is it reachable? Or because I was dyslexic and we were looking at this, we call it, is it racist? You want to take it away?
Oh yeah. The from being, I think of myself fundamentally as a DevOps person at heart. And so slamming my head into the vulnerability problem at every organization I've been at has been such a learning experience as far as the difficulty of trying to treat cloud vulnerabilities the same way that we used to treat on-premise ones. And it's because the picture we're trying to create is so much more complicated than it used to be. Even to just think of a basic asset management system where it would work if you were slow, like every time you add a new server to your data center rack and you're spinning up new VMs on it, like you can do that with a spreadsheet. Like it's still not the greatest, but it's possible. But when we're talking about Kubernetes doing automatic orchestration of what containers to deploy, how many instances of it, different base OSs, different application OSs, all getting packaged into the same libraries, the difficulty of trying to build this picture has just been absolutely crushing for people to try to move to the cloud and track things in the same way that they used to. And a lot of it is because vulnerability management has really evolved from a CVE-centric, the simplicity of like a Patch Tuesday deployment, which we're all familiar with. Like that was, most organizations still have a very well-defined patch thing for a patching process for Windows servers, where you have a control group that you roll out maybe a week after the fact, and then slowly roll that out to the rest of the fleet. But the challenge now is, what does that even look like in a cloud environment where I can't even determine if an open source maintainer has made a patch? Like, do I have my developers make a patch for the maintainer? And then you roll that all the way down through the container process to deployment. We are really involving all these different teams with different specialties. And what we're asking vuln management people to do is the hardest thing of all, which is to be an expert in all of these things, right? Like, how are you supposed to have the technical ability to both respond to cross-site scripting and SQL injection, as well as a Windows vulnerability, as well as buffer overflow with a Linux package across different distros, across different infrastructure? It's an impossible task to try to contextualize it in one person's head, all of this fix and remediation information. And so in the face of all of this, a lot of us have had to face this decision of building versus buying. And we get stuck in what I would say is this endless building phase, where at different organizations I've been a part of, you end up having 4 or 5, more than that, security engineers who you are asking to make Python scripts, manipulating CSVs, Excel spreadsheets, messing with pandas, trying to
coding.
Yeah, trying to vibe code their way out of this problem. Because it sort of is just the organic thing where we're just solving problems as we go along. And we end up stuck where we're asking security engineers to do something that we're not good at doing, right? Like a lot of the work that I was doing, some basic like BA type dashboarding, it would probably be better to ask like a second-year BA person to do, because they actually know what they're doing. They've been trained on it. They know how to do it. But we've got security people who are good at vulnerability analysis and incident response and finding and the prioritization piece. But we're having them do development work on the one side and build entire in-house products. And then on the other side, do business analyst work to try to dashboard and communicate this to different stakeholders. And so we're really putting a ton of pressure when we try to build these things ourselves to do this. And then on the other side, I could ask you to raise your hand if you've ever been disappointed when you've bought a platform, but I'm sure everyone would participate in that, where we try to buy these solutions that also don't quite fit our environment. Because what I've learned from doing this for so long is that everyone's environment is a mess in a different way. The most recent example was a company that has a lot of Java expertise. And so their DevOps team is compiling their JavaScript applications with a Java app on top of it. And if you're a vendor, like how are you accounting for that in the process you're building? And so it really is this difficulty of the platforms not being customizable enough for what people need. And then on the other side, we get stuck asking people to do things that we're not really trained at. Like my background's not computer science. My background's not business analytics. It's security and infrastructure. And so what we have to present today is the quick fix for that. And the answer is there's not a quick fix. And there's really not a single answer, because this vulnerability thing that we are trying to do is extremely complicated. And so we need to take a step back and think about what is a vulnerability management program. And the answer is that it is very different depending on your organization and your goals. Something that I find extremely useful is to be realistic about the vulnerability management program that you're trying to achieve for compliance. And that's where we play a lot of games with like asset scoping and patch management systems and like, oh, well, that's in scope. That's not, like we use this kind of scanning, but not this kind. But that just solves part of the compliance problem, but it doesn't get at what we're actually trying to do, which is create an overarching way to reduce risk for the business by actually making progress towards remediation. And I think that's been the biggest gap of this whole issue, is that we haven't been focused enough on how do we actually fix vulnerabilities. We've been talking instead a lot about how do we discover vulnerabilities, how do we prioritize them, but it creates an issue where we're not surfacing issues to developers in a way where they can actually fix things.
So, and this is one of my favorite one from Chris. The things that we should focus on is just a fraction of vulnerability. So instead of looking at the whole problem scope, we should focus on a fraction of issue. And we're here not to just paint doom and gloom on this industry, but also to give step forward, but step forward not with magic security dust. And I have some magic security dust that you can sprinkle on your favorite vulnerability management tool to make the vulnerability disappear. But no, jokes on the side, attributing what's really a vulnerability and who owns it is complicated. And I've been talking about application security and cloud security being the same and being one part of a vulnerability management program. And here I'm showing you the two things are separated. So we need to recognize that the life cycle of a software and the way we fix a software is very different from how we patch a system, how we deal with Kubernetes. And maybe containers are just the borderline that you see in there. And the way you prioritize things is very different. So if we want to do a quick exercise, and I'm going to go quickly through it, on how can you reduce the number of vulnerability by the data that you have available. You can take your 200 and plus total number of vulnerability. You can look at the one that are actually where you have exploit available and verified exploit with your favorite Vulncheck Kev, CISA Kev, any Kev that you have available out there. And then you can take your favorite EPSS methods and reprioritize the one that are more popular. Just with that, you get a fraction of the total number of vulnerability that you have available in your system to a very minute number. And then you can layer on top of that the criticality, the business element. Is these things even running? And we can touch this in a second. But I would like to also touch point on what is the concept of exploitability? What is an exploit and an exploitable exploit? Who can give me a definition of what's an exploit or what's exploitable? How do you consider something to be a priority? And when we talk to the developer and say, this is exploitable, what that actually means? Okay. A POC or a piece of code that is using a vulnerability? I would say something that is exploitable, is it used out there? This thing doesn't work. Was it a 0 day that now has become an exploit? Is it easily to be automatable? Attack vector, remote code execution, this kind of style of things? Do we have data out there, CTI, EPSS, evidence that is exploitable out there? Is it actively used by threat actors? and we have more refined evidence, is this particular exploit being used by threat actor or at scale? This is what I define exploitable. And then my favorite one, is it really reachable? Reachable from a network perspective, reachable from a code perspective, reachable from a container perspective.
I think the reason this is so complicated too is we like to talk about CVEs as though they're all the same, because most CVEs follow a pattern of, if an attacker injects this payload into this function, then an exploit can happen, or they can do something to the system they're not supposed to. But a lot of CVEs are really more broad than that, where they're saying, if you have this, that's public facing. If you use this software in this specific way, not the big log for J issue, but an earlier log for J issue was, if it's behind an Apache chainsaw server, then it's in trouble. And it's this contextualized exploitability is so complicated because every CVE is actually so different, as much as we want to try to standardize them in a way as much as we can.
So the way to approach this is to, one of my favorite one is the pyramid of priority. So if we take the vulnerability, the raw vulnerability data that usually come from scanner, we have tons of them, and we tend to be reactive on, hey, you have this vulnerability, fix critical. That's where you get alert fatigue. If you go up and up and up on evidence of exploitation, on evidence of reachability from a network perspective, from a container perspective, from a library perspective, and eventually, when you don't have any of this information, the threat type that each vulnerability carries, and are those vulnerability a good DNA that tells us, is this going to be exploitable or not? So we go from a lot of problems to a very few one. So do you want to serve us the silver bullet again?
That's right. This time it's for real. Oh, not quite. So it is still complicated, but there are at least some answers that we have for some of this. And the first thing is to recognize that a lot of our CVE data can be very chaotic and unclassified, where there are actually a lot of pieces of this that we can stitch together in order to determine the exploitability of a particular vulnerability. And one of the most underexplored, I think, is just the CWE data in particular, where there is a reason that when people do vulnerability research, they will often keep researching until they find remote code execution, which would be the CWE that's attached to the CV. And it's because they know that a remote code execution will get a lot more attention from people. And there's a reason behind that. And it's that attackers are more likely to exploit remote code execution than they are different kinds of vulnerabilities. And so when we classify data using more things that are available to us to try to connect them to the actual exploit that an attacker will do, it unlocks a lot of prioritization data. But more than just the prioritization side, I think more and more from working with different vendors in the space, from doing this, it's clear that asset ownership is still the foundation of a vulnerability management program. And the problem is that asset ownership hasn't quite caught up to cloud architecture. And really what we're trying to do when we talk about asset ownership is go from this totally chaotic mess of really this is so challenging, because I can think of different problems I've had with data management across assets based on the scanner I was using at a time. And so since I've worked in so many different companies, I've used every vulnerability scanner out there. And they all just contextualize things in different frustrating ways, where some of them will show containers as like container process paths, which is like the worst nightmare. But then you've got like, sometimes they'll have a container name, but every container is unique. And sometimes they'll standardize to like a base image, but it's not always the right base image because there's an internal deployment pipeline. Or you have different ways to categorize software libraries. And different container scanners pick up different software libraries than other ones. And there's just a mess of complexity based a lot on your scanner is going to interpret exactly the particular frustrations you've had trying to standardize this data across containers, cloud assets, and the like. And so really what we need to do is figure out, take a step back and say, how do we identify the owner of these particular things? And finding the owner is way more complicated than it should be, because a lot of tools try to do this, especially automatically, by looking at like git commit history. But the problem is developers aren't typically around for 10, 15 years at a company. And usually that's where most of the vulnerabilities are. And so the person who committed the vulnerability is just no longer there. And it's like, okay, well, that doesn't work. And then we have these older pieces of infrastructure that don't have a clear asset owner, or the lines between who owns an asset changes multiple times as a piece of code is moving to production. And so a particular app team might own the code for their app, but another team might be like the front end team manages all of the libraries for that application. But then the DevOps team might own the pipeline or the infrastructure as code for certain pieces of the infrastructure, but not other pieces of the infrastructure. And then on top of that, like as teams change, different tagging mechanisms change. And really it just gets at, there's a huge data problem in trying to find the owner of a particular asset. And what's really important is when we look at these vulnerabilities is to not focus on like a CVE by CVE basis, but to try to look at the asset that it's on and figure out who is even the right person to try to fix this. And it's only when we've contextualized all of this together that we can move from this crazy vulnerability data that's just coming in and it feels like a giant mess because we're trying to figure out what person to fix each CVE because we don't have a clear view of who owns this asset, which is really what we should be striving for as we move to trying to fix this stuff in the cloud. So who owns it isn't important. And then when do we need to fix it by is the last piece that we need to communicate to developers.
Absolutely. So if we try to move from doom and gloom to actual solution, the full question and the full horsemen of the apocalypse that we need to address is who owns assets in the software world and who owns assets in the application world. What are those assets transforming into? If you take a container file, it morphs from a piece of code into something you deploy in a registry to a running nodes that run somewhere. So that is a concept that we call lineage. And different team owns different part of that. So the development team owns the code piece of it, but the operational teams normally owns the running of it. So we need to recognize that container are really the hinge point between environment and application. And most importantly, app traceability. So which app get built in which container that can run where, because that's where things get very complicated. So if we want to summarize, attribution, lineage, traceability, and code to cloud reachability are the four horsemen that we need to address. And addressing a container, and apologies if the image is not shown very much, but you have on the right a running container that you can trace it back to the number of images that are in your registry and the number of versions for each image that is actually stored, and not all of them are actually running. So the first scheme through this could be just look at your container that are running, which image is actually running, and then screen down all of the vulnerability that traditionally your CSPM or your favorite container scanner will very likely give you happily, saying, hey, look at how many problems we find. Because I think, James, you mentioned it on your talk yesterday. We measure the quality of security scanner by how many problems they can find, not how many solutions it can give us, and not how precise those things are. So, and unfortunately, we are the problem as industry, not vendors, but as consumer, that we try to measure scanners by the number of noise and the number of things they find, not the number of things they give us to remediate.
Well, this creates such a mess because often in organizations, like you have different teams. So you have an application security team that owns all of the scanning on the left, and they might even themselves use several different vendors to do that scanning. And they often also have container scanning as a capability, which is why containers really are the linchpin that tie this whole thing together, where the infrastructure team might have multiple CNAPP tools that are scanning the container registry. Then you have the AppSec team also having tools that scan the container registry. So you have a ton of duplicates just from that scanning alone, but then you layer in all of the code scanning that's happening and SCA scanning against the deployed image, and the level of deduplication and data standardization creates just a massive problem across these teams that sometimes don't even communicate.
Yeah, so ultimately, even if we look at just container, sometime to fix a problem, So sometimes when you scan a container and you get a number of vulnerabilities, sometimes you need to decide, is this problem coming from the application or the base image or the source image? And if we take an approach, a simple approach on up there is Sankey YAML that has a vulnerability. That particular library get built in an application that then get built in a container. And that is your pre-live before you deploy an application. So just in that space, you probably have scanned the application with 3 different scanners. A container linter, an SCA tool, a SaaS tool, and you might have probably have received already twice the number of vulnerabilities. Now, you deploy the application in your live environment, and that's a number of versions that get scanned. So you already are 3, 4, 5 times the same vulnerability reported by different tools a number of times. And then you have your favorite CSPM that report your running images. So just in that particular journey, you have multiple vulnerabilities that are the same vulnerability in just different states being reported. And that's one concept we call contextual deduplication. That's something we've been really focusing on as Phoenix to actually remove the libraries in a container that are not fixable in that container, but really tracing it back to which repo and which library you actually need to recommend to your engineering team to fix. Because ultimately, you don't want to report vulnerability. You want to recommend remediation to the right folks, because that's the only thing that's going to get an action out there. So what we discussed in that previous slide is what I call reachability analysis, or the 4 reachability analysis methods. And I'll invite you to any vendor that you go through and they mention, we do reachability analysis. Ask them, which of the 4 reachability analysis do you do? Do you do reachability analysis on the code level? So is that particular library being loaded or reachable? Do you do reachability analysis at container level? Is that container being reachable from a network perspective, or is that particular software being loaded in a container that is actually network reachable? And then you have your favorite CTI or network reachability analysis. I'm not going to give you a master class on reachability analysis, but what I want to touch on is, after all this talk, what we want to get to is what are the critical that really matters? What are the things that we can switch off? And what I like to do is switching off vulnerability, not reporting more, but actually reporting less vulnerability. And to report less, you really need to look at, is the particular vulnerability exploitable? Is that particular vulnerability reachable? Is that particular vulnerability a critical in this particular context where I'm deploying? And most importantly, who needs to fix that? So if you walk the path to CVSS, I will say you probably are in the ancient Roman time where people are building weapons with bronze or maybe silver. Like, those are not the tools that we can use to measure risk. What we should measure risk is, and this is the journey that every company goes through when trying to do an implementation of a vulnerability management program, from traditional CVSS to something more enriched, because ultimately it's about how do I fit all of these data points into a matrix system that tells me ultimately, do I fix it? Do I ignore it? Do I look at it tomorrow?
I'm just picturing perfectly the CISOs I've worked with, and we buy a scanner and they just say, show me how many criticals. How many criticals do we have? And then it's like, all right, we have 200. And then over time, as the months and the years go by, they start getting more nuanced slowly with that question of like, all right, well, the number of criticals, like, what are the real criticals? And then I just remember constantly be like, James, no, what are the real criticals? And I think it gets to like, that's a very complicated question that the number of CVSS criticals doesn't remotely tell us.
Yeah. So if you want to take something out of this, what we use in Phoenix and in general, what I like to use as part of a risk-based approach is 4-dimensional risk. So CVSS is one of them. How bad is potentially a particular vulnerability? Your business context, where that particular vulnerability manifests in terms of how important is that application or where that application runs, and that where that application runs gives me the other two dimensions, that is reachability analysis. Is this particular application running on a set of container? Yes, no, or an image that is actually running somewhere, and is that image or that running image actually network reachable? So that's the concept of the different concept of reachability analysis. And then is this particular vulnerability actually exploitable? And do I have evidence of exploitation? And that's a very nuanced question. And you have different data points depending on different style of vulnerability. From a patching perspective, from a traditional library perspective, you have EPSS, CTI, and other methods that tells you attackers are actually using this vulnerability right now. From a library perspective and from a software perspective, that's way more complicated to answer that question. So you need to have different data points for different type of vulnerability. And that's why I like the concept of probability of exploitation, because it's driven and it's different from each type of asset that you own. And if you want to do things at scale, again, I'm going to go back to application security and environment security. You need to really make these two environments correlate to each other, but need to recognize that they are different beasts. And one method of approach that I used to like when deploying things at scale back in my financial institution days was you need to give the freedom to teams to operate and decide how they want to tackle this problem, because SLA don't help anyone. Who has used SLA in this room before? Service level agreement. How many times you seen SLA being missed? Lots of time? Yeah, because SLA is a flat line that you say, this is the timeline where you should demarcate, and they are consistently getting breached and consistently getting missed. Another approach that I like much more is this is the bar that you should hit from a risk perspective. The way you're gonna tackle that is completely up to you. So one of the methods that we use in Phoenix, and it comes from our experience back in the financial institution days, was this is the level that your application need to hit in terms of risk level. You as a team go and figure out if you're patching a system, if you tackle a library by library approach, if you fix an entire build file, if you decommission an entire application, it's completely up to you as a team to figure out the approach to best hit that target. But you give and treat engineers like adults, not like toddlers with SLA.
Well, I think the key thing that I found helpful is to communicate to them that this is not going to stop happening, because a lot of times they can get a ton of vulnerability tickets maybe over the course of 3 months and say, all right, we're going to take an engineer for a sprint and we're just going to heads down fix all this stuff. And then they're surprised when 3 months later there are a ton more CVs and they're like, didn't we just do all this work to fix it? And so it's just communicating, like, how can we strategically, like, what is going on that we can't have a sustainable patch process on this service? And then how can I help you as a security stakeholder who can easily get up the executive chain a lot more easily than like a junior software developer can, to say, how can we as a team work towards these things? Because we ultimately have the same goals. Like, developers also want ephemeral infrastructure. They want elegant deployment systems. They don't like flaky applications and flaky tests. But the problem is they can't get tech debt prioritized. But security is sort of the secret weapon to, hey, if security is saying we have this tech debt problem, developers saying we have this tech debt problem, DevOps is saying we have this tech debt problem, we need to actually fix this stuff. It allows us to go together and make a business case for it, as opposed to just constantly trying to, every 6 months, we're surprised again that there are more vulnerabilities on these images.
And the way we treat risk on all of this, and if you want to take something away, don't reinvent the wheel. Like, risk is risk and has never changed. And don't believe anyone that tells you we have a new way to tackle risk, because that's BS. So just use the basic formula. How bad it is, what is the likelihood of an event to potentially happen? And that's where you can play with different points. And that's where you can play with different typology of asset. Like, is something reachable? Is something likely to be exploited? And those are the questions that you can answer in what we call probability of exploitation, what risk call really the likelihood of exploitation. And then how bad it is from an impact perspective. So I've been teasing you about a threat-centric approach. I've been talking about threats all this time, so let's show really what it is, a threat-centric approach. So from all of the vulnerability we're looking at right now, a really basic effect of, is something exploitable, is something not exploitable? But can we go beyond that? Can we look at the vulnerability and try to understand, do we have a DNA of the vulnerability that are exploitable? What are the characteristics of specific vulnerability that turns into a ransomware attack, a zero-day, something that threat actors use and look at more and more? So that's the question we started asking ourselves to get to the point. And to answer that question, we look at two categories of problem, CVE-based and CWE-based, because in traditional patching method, you have CVE-based vulnerability, but in the software world, you have CWE-based. So can you find a common denominator that tells you the DNA of specific vulnerability that leads to an exploit, a zero-day, or a ransomware attack? And are there patterns that are common between all of them? I'm going to skip quickly this part and look at the juicy part. So one method that we looked at originally was, can we trace back vulnerability with CWE, CAPEC, TTP, and MITRE attack? And that led us somewhere initially. But CWE are missing most of the time. Chris has done a fantastic job on the talk yesterday on covering the gap between CWE. And we apply the same methodology or a similar methodology on threat type to actually classify, and you have the threat mapper up there, to understand really the DNA of specific vulnerability, and invite you to play with it to understand the DNA of specific vulnerability type. And if you want to look at the methodology that we use and all of the thought process, because it's a lengthy thought process, you can look at our white paper down there. But if we just look at the vulnerability type, and James mentioned it before, CWE are usually not looked at because 50% of the MVD is actually not really being classified with vulnerability. So what we did is using an LLM-based approach to actually classify and reclassify vulnerability in these two methods that is called root cause and threat impact. And we've seen a fairly good distribution. We haven't seen any emerging threats from all of the NVD reclassification. We looked at trending between the years, and has something changed between 2018 and onward, where we kind of can demarcate the born of modern vulnerabilities versus the old vulnerabilities. So if you look at, for example, cross-site scripting, we've been reducing those classes of vulnerability or denial of service. What we see in remote code execution raising up from the ranks. Now, so far, we haven't seen anything that give us a good indicator or of that particular DNA element of a vulnerability that gives us good exploitation. So we've been looking at the wrong data. So we start looking at all our threat intelligence and open source threat intelligence available data, and we start seeing patterns. We start seeing the rise of remote code execution, buffer overflow as a threat impact. And over the years, this is much more clear. Remote code execution has been used consistently as a method of exploitation for zero-day, as well as memory corruption. And it's logical, if you think about it, as an attacker, what do you want? You want something that is remotely triggerable, that is going to enable you to move across exploitation and limiting of the memory and get above the boundaries. And then we start looking at from all of the ransomware data that we have available, as well as CISA flagged as ransomware data, at that particular threat type and threat impact that are relevant. Again, remote code execution and memory corruption were the one that were more relevant as a DNA method of something that led into an exploit. And as well, it was so clear that almost 40% of all of the exploit on a set of 400 ransomware use vulnerability have the same characteristics and same impact type. So we start using this information to start predicting this vulnerability going to be likely to be exploited? And can we use this information to predict if something's going to become a 0-day or if something's going to become an exploitation? And the answer is yes. We have more data that are available, but I'm not going to bother you with too much data because it keeps on saying the same thing. So we used fundamentally a method that reclassify or tell us if this indicator are a good indicator of exploitation or ransomware mess. Then we can give or use this as an additional flag when we don't have any other method of information. This is particularly true in software where you don't have any threat available information, or in your CVE base where you have millions of vulnerability. Where do you focus? You focus on the one that are more likely to be exploited, more likely to be triggered remotely. So again, if you want to look at how we use this threat and threat impact, you can scan this. This is available as part of our threat intelligence and threat visualization across code, clouds, software, and so on. And if you want to look at the methodology and more of the data that we use as an approach, there is the white paper out there. So I'm going to leave some room for the question, but in conclusion, did we answer the question, did we give you the silver bullet to prioritize vulnerability, or did we give you the silver bullet to shoot yourself when you see a lot of vulnerability? We hope that in all of this journey, we're giving you the magic security dust that helps you discerning between different vulnerability and different vulnerability categories and realizing that this piece is complicated. And the way you approach software vulnerability and the way you approach library vulnerabilities and container vulnerability needs to be different, but the method that you use to prioritize needs to be consistent so that you can give your engineers a good indication of what to fix first. Thank you for your time. Questions?
For the folks in the room, if you have a question, please raise your hand and one of us will bring you a microphone. Virtual
because they're
folks.
so thoroughly satisfied with how to fix it.
Did we shock you? Yes.
Virtual folks, please place your questions in the Discord.
First of all, it's very nice to see that we are doing similar vulnerability prioritization in our company, and we use the existence of the exploit as one of the criteria to define the priority of the single CV. However, the fact that the CV can be exploited doesn't mean that it's exploited.
Correct.
So we enrich with cyber threat intelligence sources the behavior of each CV to understand its exploitability towards the war and against our company. Of course, if we detect anything which is related to our company, this triggers another parameter, which is the popularity of the CV. So if we, for example, from a web application firewall or any kind of ADR, etc., we detect any indicator of compromise that any indicator tells us that a specific CV is exploited against us, this is increasing the priority of the specific CV. When the CV is just exploitable, we say it is disclosed, the exploit is available, but until it is not really exploited, let's say exploited in the wild, until we don't have a real evidence that this CV is getting exploited, we do not increase the rating of the specific CV. We keep it in a, let's say, downside, and we keep it under monitoring, especially for those specific CV that can be more dangerous. And whenever then we detect something, we increase the rating. In regards of the SLA, what we have detected as a very, very meaningful for the team who is going then to apply the remediation of the specific CV is to communicate to them when there is a patch for the specific CV. So maybe it's not in every company, but in our company there are some team that applies the patches, another team that let's say that monitors the network. To the team that monitors the network, we reach out to apply the mitigation if there is a specific signature for the CV, but patching team don't need to know about the CV until there is not a patch for the specific CV. So we as a cybersecurity, we are trying to let's say to split the responsibility within the company and to ensure that we talk to every team. Actually, we talk to the exact team who can really actionate something against a specific vulnerability. And with this method, whenever we go to the team with the patch and we tell to them, look, this CV was released 3 months ago. We applied the mitigation in the meantime, but now you can apply the patch. Then SLA are getting quite well respected. We have a very tight SLA for critical because we issue our own critical rating. We never copy the vendor rating. And in that case, we have 6 days SLA for patching critical vulnerability worldwide. And I will say the team is going very well, is patching within the SLA.
Yeah, that's a very good point, because you actually don't have discovery time SLA, but you have remediation SLA, what we call remediation SLA.
Discovery time SLA are on us.
Yes.
We take the responsibility of the discovery SLA, and we ensure that the correct team is informed about what they have to do. On the other hand, network team don't care about patching. They care about deploying the signature. So we balance somehow the risk in this way. And for the part of Kubernetes, which was quite interesting, a question that I have for you. Our approach is currently to not wait for any detection. So we are working at registry level, and our aim, this is a big project which is currently under development, but our aim is to scan the repository before any kind of deploy, before any kind of container image, and tell to the team what image they can deploy before it is getting runtime. Of course, if it is something that is already running, that has a higher priority. But this method is helping us also in kind of giving to the team, to the global, to everyone, kind of awareness of their library, of their registries. And what we did basically is we created a rule that every kind of application owner who wants to use Kubernetes has to load their repository in Azure Container Registry, AWS Container Registry, and we scan directly that part.
So you scan all of the version of all of the container that get generated.
The full registry stack. And then we get back to the application owner with a list of libraries that can be used. There are, of course, some edge cases when there is a business reason that this specific library has to be used. But in that case, we apply a specific, let's say, sync calling around the library. We keep the library under the rider. And then if something changes, for example, there is an update of the CV, the CV is getting publicly exploited, whatever, we close it directly. We give to them a few days and they need to change their library as soon as possible. This is helping as well for the part of the SLA to reduce the overall risk. And yeah, that is what I wanted to ask you. Why you think we should be waiting to scan the? I don't really like the fact that the image is already running, is already vulnerable. Then we scan it and we detect that this is vulnerable. And we get back to them to say something. So I would like to handle the problem before it is getting in runtime.
Yeah, that's shift left. But then you have as well. Thank you for the question. It's a very rich question. So if the image is running, like the reality of it is that organizations are not blocking deployment before the image gets run. So a lot of us have started looking at container, cloud, and start scanning things when things are already in production. Second, you have libraries that become vulnerable when they're already deployed. And the challenge that you have is really, do you look at all of the image that you have in all of your registry? Do you know that if that image is running, and even if you know where that image got generated? So that's kind of the question that you should be asking. If you have the leisure to block all the deployment before runtime, that's even better, because then you stop the bleed before the things becomes vulnerable. But a lot of organizations don't have that leisure. Even in financial service, we were struggling to block container image before they got vulnerable. And sometimes because we inherited a lot of deployment, we had to fix those and we had to trace back where is that particular image coming from and which team needs to maintain it. But thank you for the question. Any other question, or I think we have a minute. If not, we're Phoenix Security. We're out there if you want to keep on chatting about vulnerability. But thank you so much for your time. I hope I'll be enlightened a little bit and giving you a different way to tackle vulnerability. Thank you.